This is an overview of the COMA UI front-end system. It's built in JavaScript, CSS, HTML, and uses Node.js. The GitHub repo is public, and you can access it here. It also uses a flowchart that's generated by the library Go.js, and I will explain this in a minute. So, just a quick overview. This is the current state of the front end. On the left side, there's the module selection menu, and this is a collapsible menu where you can select different nodes to load into this environment. So we call this the environment, and it is a Go.js powered environment. So if we want to add modules to this, there's a bunch of different modules. So in the future, this will be connected to the database. There will be a lot of different options here. Currently, the only two that I can use the cholera, which connects to a fake data set on the node backend here, or what I normally use is the CSV file. So you see when you double click on it, a pop-up comes up, and there's also a inspector card. So these cards can be collapsed all the way, expanded fully. They can also be dragged to a different size if that's something that you wanted to do. Um, so see the CSS needs to be fixed here. It's just an issue with the buttons, something simple to fix. We're going to choose a file here, and we'll choose this one. It's a COMA file that I've been using. You see data popped up here, and actually the data module popped up there, and it connected with a link automatically. So the data, so whenever you click a module, it's going to fully expand its inspector card, but if you collapse it, you can see the other one's still there. This is just, I use this for testing. It's just a quick way to see which data fields are there and what their data type is. And since it's loaded from a CSV file, all the data types are calculated, are determined automatically. And well, I'll explain how you can change them as well. So um, the data, so the colors should be linked. It still may have some bugs in it, but you can connect now the data to either a filter or a data conversion processor. So the first one I'll do is to show us the data conversion. So a data converter has this option. So um, basically, in the code, the data conversion is here in conversion functions. And so these conversion functions are just basically objects, right? So we have the name, and then we have this function, and it's going to apply this function to every single element in the data array, and it will output it to this field. So it's going to create a new column in the data table, and it's in this case, it'll be MJD. So we're going to select Julian date to MJD, and over here we're going to need to select the Julian date field. And then we're going to convert it, and a new data object appears. So this data object now has this MJD field, whereas this one does not. You can also apply filters. So if I want to apply a filter to, I can either link it here, and it's going to link that. And so in this case, you can see that we have these different options. And so these can be scaled with a minimum maximum using the slider. And if we wanted to, say this didn't mean to be a number, we can actually change it to a date, and it'll automatically generate a date based on milliseconds. So yeah, and you can change it back. So the one issue that needs to be dealt with in this case is that this isn't auto-populating to the correct field. And additionally, so some of these, such as telescope, these are categorical data types, and I haven't implemented that yet. So another thing you can do is flip the minimum and maximum. And so if you, for some data fields, the astronomers may wish to have the maximum on the left and the minimum number on the right. And so now this will control this side, and this will control this side. And so when the data is coming from the server, you'll know which fields are likely to want to be flipped, and you can do that automatically. And my goal eventually is to use was to set these three buttons up as an option menu and hide all these extra things, and possibly there'd be more options for different kinds of filters and in the future. So we can apply these filters, and then we can do outputs. So just do show first this line chart. So again, just some issues with the button CSS. So let's do, we're going to do modify Julian date, and we're going to do, well, it doesn't really matter. We'll just pick, say, true anomaly. And this will give us some sort of graph. All right, and you see, so here we can actually scale it like this. And so, and you can drag it up like here, you can slide it along through the time scales. We can change the colors. And so these are themes. The ones I'm using here are provided by eCharts, but they can be custom built, and these charts can be saved as JPEGs. Additionally, we can do a to CSV. So let's look at this one. So in this one, again, we have some CSS issues. We can, if we click these columns off, they won't appear in the table. So we can preview this table. All right, you see the fields that I clicked off have disappeared. Like telescope, for instance, is no longer here. And if I click it back, it's back. All right, so like I was saying before, this is categorical. And so what we can do now is generate a CSV file, and it will create a CSV file with the data. Okay, well, there might be an issue with that one. We'll have to look at that too. But you get the idea. So that's how this works. And again, if you want to look back here, you can see all the different cards that are here. And some of these have pop-ups that do things, some of them do not. For instance, the filter, there's different options that you may want to use later that these can be implemented, or these pop-ups can be turned off. So now that we've gone through the basics of how the UI works, and the design pattern. So the way that I've designed it is that there are a series of managers that basically are all connected to a central hub. And so it uses something called chain of command design pattern, where messages are going to be passed. So for instance, if a message starts at the inspector card, it'll go to the inspector card maker, to the module, to the module manager, and then eventually to the hub if it's for one of these other components. The hub has access to all the different managers. And so when a message comes in, say from the module manager to the inspector, the hub will be the one to call the inspector functions directly. And no other components will ever communicate directly. All communication with the middleware is done through the worker manager that generates web worker threads, and it will communicate with them. Again, here's just a picture of the UI. And so here's a list of all the things that the managers are responsible for. And so the module manager, which is here, and this is the most connected one. So modules are these are individual modules, and they exist in the environment as a Go.js module, which is basically a graph node, and they also exist in the application software as a module class. And the module, for instance, so the module class, each one of these, so for instance, a source module, we'll take the CSV source, right? So this is CSV, and CSV is going to inherit from source, which inherits from module. And so they all have, so they all inherit these functions. And so and then I won't go into this right now. I'll go deeper into detail in the actual module section. Okay, where is it? So you can look through these. These are the responsibilities for each manager. So communication is done using a publisher observer design pattern. And so the way that this is set up is that each module has an instance of a publisher if they are in communication with the others, and I believe they all do. And so a publisher basically will take a subscriber, and the subscriber is essentially a message handler. So if when when a subscriber instance is created, it passes a message handler function, and then that function is bound to the subscriber. So whenever a component publishes a message, they simply pass the arguments, which is a message class. They'll pass it to the publish message function, which will then pass it to each one of those message handler functions, and then each component that will then handle the message independently. And so it should only be going to one it should only be going to one different component at a time because of the chain of command way that it's set up. But it could be changed if future development feels that that's a better way to do it. It's really easy to implement it as broadcasting. So communicating with the server, and the server is here as well, and it's actually, for simplicity, it's just called server. And so the server will basically, so the clients will talk to the node server first. And so all messages from the clients, all communication with the client will be funneled into this Node.js server. And then this Node.js server will then communicate with the Python Flask middleware. And we're communicating with the middleware through a RESTful API. And so if you look, I'll show you. So all the node modules that I've built for this, for the node middleware, are in this custom modules folder. And I'm not going to go into too much details. However, the job manager is the most important one. And so what will happen is the job manager will, when a new request comes in for data from the server, it's a job. And so this job will be put into the job queue, right? And so that's done here. So add job. And what will happen in the add job queue is it'll check to see if there's an available web worker thread. So the web workers there's a pool of web workers, and they are in a queue. So right here we have initialized web worker queue, and it's only set to 3. This is probably going to want to be higher than that, but for testing, I just had it set to 3. And so if there's an available web worker, the job will be given to the web worker, and the worker will then communicate with the Flask server through the RESTful API. And so I only have get and post implemented at this point. If we can do puts and deletes as well, but for now, this is how we're doing it, and it's relatively simple. And so if there's no job available, what will happen is the web worker, the job will sit in the queue until a web worker returns, and as soon as a web worker returns, it'll check the job queue, grab the next one, next available job. So that's the basics on how this works. And for more detailed information, just check look through the other parts of the wiki, because I'm going to put a video for each one of the main sections.